This clip is looking at the charging and discharging characteristics in terms of voltage and current for a capacitor using a DC supply. Just a wee reminder that you can think of a capacitor as a bit like an electric beaker. Right? The bigger beaker here would take longer to fill up, with water than the smaller beaker would. And likewise, a larger value capacitor would take longer to charge up than a smaller value capacitor. Now they're normally connected in series with a resistor, and you can actually think of the tap here as being the resistor. Right. If I fully open up the tap, then I get a good flow of water, right, which will be my current. I'll get a high value, whereas if I increase the resistance, the current gets less and less and less until it might actually not flow at all, depending on the values. So take that on board when we actually look at the values on the voltmeter and the ammeter as they charge and discharge. So this is our basic setup. I've got a power pack here, power supply. It's giving me about 5.5 volts DC. It's then connected to a capacitor. That's the big sort of blue cylinder you're seeing there. It's then in series with a variable resistor, which I have here, and I've got an ammeter and a voltmeter. So the voltmeter is connected across the capacitor, and the ammeter is actually in series with the capacitor and the variable resistor, because remember, what goes through one has to go through the other one in a series circuit. I know this looks quite a stack of wires here, but the top one is the one that's really important here, because this is going to allow me to charge and discharge the capacitor, right? So I can actually take this connection out here, which would allow me to charge up the capacitor, put it back in again, and would actually discharge it. Alright? So the first bit you're actually going to see on the voltmeter and ammeter here would be the charging characteristics at a set resistance. Right? I can actually adjust it using the wee dial here. Right? So now ready to actually discharge it. I'm only interested in you looking at the ammeter and voltmeter now. I'm going to take that top red wire out now. So pay attention to what happens to the current, on the ammeter, and the voltage, the potential difference across the capacitor, when I take that wire out. So you can see the current has dropped off almost to zero, and the voltage gradually increased, didn't jump up to 5.5, gradually increased until it's now sitting about 5.5 volts. That's how you would actually know a capacitor is fully charged. Either the charging current would be zero, or the voltage, the potential difference across the capacitor would be equal to the supply voltage, in this case 5.5 volts. I can now discharge it again. And you can see how the voltage drops to zero right away, and the current has actually increased. So I've now altered the resistance of the variable resistor. I've actually decreased it, and you can tell by the fact that the current at the moment flowing through the circuit, because I'm actually bypassing the capacitor at the moment, is higher than it was to begin with. I can't change the value of the capacitor in this circuit, I'm afraid. It's a fixed capacitor. Now if I take that top wire out, I want you to pay attention to the time it takes for the current to drop off as it charges, and the potential difference across the capacitor to rise. Now if you compare that with the first one, that's happened an awful lot quicker. It's much easier to charge up the capacitor because the resistance is less. You can still see it's still somewhere around about 5.5 volts on this meter here. It's the same one, it's just taken a lot less time to actually reach it. So when you decrease the resistance, it's much easier to charge up the capacitor because there's a bigger flow of current. I've now increased the resistance of the variable resistor. You can see here that it's a very small current that's actually flowing through the resistor at the moment. So again, I want you to pay attention to what happens to the time it takes for the voltmeter reading to actually reach 5.5 volts. Remember that's what the supply is given us. So you can see it's taken a good bit longer to actually reach it, that 5.5 volts. It's simply the fact that there's less current flowing, right? So it's going to take longer for the capacitor to actually charge up, and that's all due to the fact I've got increased resistance. Again, I now know that this capacitor is charged because my current is now reading 0, and my voltmeter, the voltage across the capacitor is the same as the supply voltage. That's how you know a capacitor is fully charged. Now it's the same for discharge characteristics. It's going to take longer for this one to discharge, simply because it's having to try and flow through a bigger resistor. Now the previous ones would have discharged an awful lot quicker than this, okay, because the resistances were much lower. So I can discharge the capacitor now. It's pretty quick actually, because the resistance isn't that big, but you can actually see there is a difference in terms of the charging and discharging characteristics. So I've now drawn a couple of sketch graphs of the charging and discharging for the voltage. Okay, the blue line is going to be the voltage across the capacitor, and the green line would be the voltage across the resistor. Now remember, I only had 5.5 volts, okay, for the supply. So at all times, right, these two values, the blue and the green ones, would have to add up to give me whatever the supply voltage was. So at the very beginning, all the potential difference, all the voltage would be across the resistor, and it would decrease as the voltage or the potential difference across the capacitor would increase. Now, the voltage across the resistor would then reach 0 at the same time as the voltage across the capacitor would reach whatever the supply voltage was. So when this starts to level off there, that's the supply voltage. If I then discharge, I'll just get the opposite. Okay, as the voltage of the capacitor decreases with time, then the voltage across the resistor would increase with time. And again, they would actually reach supply voltage here and 0 at the same time. Okay, that's what the dashed line is trying to represent here. Okay, so these will be the classic charging and discharging shapes of graph for a capacitor. So I've done the same thing now for the current. Now I've only used the one colour this time, because remember, with it being series, the current that's through the capacitor will also be the current that's going to be flowing through the resistor. Now the current starts high and then decreases to 0. Remember, I said to you, this is how you can identify the capacitor is fully charged, is when the charging current reaches 0, because the capacitor is acting now like a block in the circuit. Okay, it can't take any more charge. Now remember, this is with DC, so what I'm doing is I'm putting electrons on one side and I'm effectively taking electrons off the other, okay, until I can do that no more. So when I discharge the capacitor, the electrons are actually going to flow in the opposite direction from the charging electrons. Alright, so if I was putting the electrons on the left hand side plate here of the capacitor, alright, they were going in that direction to begin with. Well, when I discharge it, they're going to be going in the opposite direction. Alright, so what I get is this value here and this value here. Alright, it should be the same, but they're just in opposite directions. Now remember, again, once all the charges stop flowing, the current is going to be 0. So again, I can know that the capacitor is fully discharged this time when the current reaches 0, because there are no more charges flowing in the circuit. Alright, the time it takes is going to depend on the value of the capacitor. Bigger capacitors will take longer to discharge. It's also going to take account of the value of the series resistor, because remember, a large resistance means it's going to be a small current, which means it's actually going to take quite a long time to actually discharge. A smaller resistance would mean a larger current and it will discharge quicker. Okay, so I hope you can now understand the charging and discharging characteristics for a capacitor.